All right, so here we go. This is the fourth of the first 4 15-minute videos for HACCP. Now, this one's only going to be 10 minutes long because we're looking at a 50-minute class. So I go through and I understand that. So it's one of those of just keep moving. We finished up here as far as preventing physical hazards. Biggest thing is training those employees to identify potential problems. If you can get buy-in, that's how it's referred to, buy-in from your employees. If they too want to go through and make a safe product, it'll be a lot easier. Okay. If you are managing a line and you can get those employees on the line to want to go through and make a safe product, your life will be so much easier. Prevent biological hazards. Ensure thermometers, chart recorders, etc. are maintained and calibrated properly. Now I'm going to go through and I'm going to upload a couple of videos and a couple of PDFs as far as going through and looking at some different thermometers. One of those is going to be a bimetallic thermometer. One of those is going to go through and have a nut on the back of it so that you can go through and you can use the nut to go through and adjust what the temperature is showing on the thermometer. So it's one of those of your employees, if you're running a line or if you're in a plant, they can too go through and adjust those thermometers to make it so that your job is easier or faster or whatever. You need to watch people. Only trust yourself. Okay? Always make sure that you trust yourself, because in a situation like that, if it comes down to an unsafe product, there are going to be some fingers being pointed, and you want to be able to know for sure that you have done everything you can to make sure that nobody died from what you did or did not do. Perform random but statistically reliable microbial examinations of incoming products and materials. Evaluate product consistency as far as how much fat is there, what's the diameter, what's the water content, etc., to ensure that cook and cool temperature goals. How fast does it cool down? How long does it need to stay up at that temperature? Are met. Fluctuations in the product may prohibit products from meeting time temperature requirements. If it's got too low of a water content, it may dry out faster. That drying out faster may go through and change how long you need to go through and cook it. Properly training those employees. If you, like I said, if you go through and you have them helping you, it makes a world of difference. Properly train employees regarding hygiene, product rework, and SSOPs, GMPs. Remember earlier we were going through and discussing as far as hygiene, as far as those employees going through and washing their hands at the restaurants that you go and eat at. If they are doing what they're supposed to, then you don't have to worry about those recalls and those outbreaks as much. Now, don't get me wrong, they could still happen. Accidents happen. But there's a big difference between somebody forgetting to wash their hands and someone purposefully not washing their hands. Yeah, I will tell you, it is a sad state when you can go to an academic institution and go into the restroom and peer or a colleague, you know that they did not wash their hands after using the restroom. They say, hey, and walk on out. Makes me shudder. Anyway, principle 2. I know, 7 principles. We're principle 2. Got a ways to go. Determine CCP required to control the identified hazards. CCP, critical control points. Critical control point, any step in that procedure to where a food processing system at which a control can be applied, and as a result, food safety hazard can be prevented or reduced to an acceptable level. If you cook it, how long do you need to cook it? What temperature do you need to cook it? Control point is just basically going through and saying where you can control it. Critical control point is where you can go through and you can prevent that hazard. Okay, difference there. This is a decision tree. This right here will help you stepwise, much like that flow process diagram. This right here will help you go through and identify, hey, is it a CCP? Is it a real concern? So you go through and you just walk yourself through it. Do preventative measures exist for the identified hazard? If your identified hazard is biological, are there preventative measures? If you go through and you say yes, hey, we're going to cook it, that would be a yes. Does this step eliminate or reduce the likely occurrence of a hazard to an acceptable level? Well, hey, if you cooked it enough for a high enough temperature, you'd say yes, boom, you've got a CCP. Simple and easy. Just walk yourself through the steps. If you go through and you say, no, hey, it doesn't go through and reduce it, then it's going to go through and give you another question. Could contamination with identified hazard occur in excess of acceptable levels, or could these increase to unacceptable levels? If we go through and we're looking at hot dogs, do preventative measures exist? Yes. Does that step eliminate, hey, is there still a chance to where something could happen as far as that hot dog after you cooked it? Yes. So that would ultimately be no. Does the step eliminate? No, because you could have post-process contamination. Could contamination with identified hazards occur in excess of acceptable levels? Yes. Will a subsequent step eliminate identified hazard or reduce the likely occurrence to an acceptable level? For a hot dog, to be quite honest, you would have to say no. Because, hey, you may go through and dip it in sodium lactate. You may go through and put it in some type of wash or something like that. But there's still a chance that there could be a problem. So you'd say no, and that would be a CCP. A simplified decision tree, would a loss of control at this point result in a realistic risk of injury? Now, realistic doesn't go through and say, hey, we've got a plane that could be flying overhead, and that plane could crash into our plant and go through and cause physical metal detection, equipment to be needed because now the plane has crashed and parts of the plane are in our hot dogs. Not realistic. Okay. So, simplified one. Real simple. Here we go through. Attachment 4 walks us through this process step. We go through and we're still working on our pork sausage. We go through and we have our process category. We go through and we're identifying the different hazards, biological, chemical, physical. Receiving trim. We're receiving the trim from another company. Could have metal fragments in it. Okay, so we go through and we say it's physical, metal. Then we go through and we answer the questions. Question 1, do preventative measures exist for the identified hazard? Yes. Okay, so we go through and we say, yeah, can we go through and have a preventative measure? Yes, we can go through and we can have a metal detector. Okay, that'll work. Does this step eliminate or reduce the likely occurrence to an acceptable level? If no, move to the next question. Right? So it's one of those of, hey, you work your way through the process. Right? Some common CCPs. Chilling to temperatures that minimize microbial growth. Cooking to specific temperatures for exact times in order to destroy microbial pathogens. Pathogens are the ones that are going to make you sick, just as a reminder. Processing procedures such as filling and sealing cans. Product formulations such as the addition of cultures or adjustment of pH or water activity. And slaughter procedures. These are all CCPs as far as slaughter. You've got to go through and know that slaughter is a major problem. Just because you have microbial contamination or microbial presence within the viscera, within the guts. So it's one of those of, hey, it's always there. You understand it. You just got to go through and work around it. Critical components associated with CCP. If you're looking at retort for canned foods, that's the canning process. Initial temperature, fill weight, product composition. If you're looking at a broth, which has no solid particles, versus a potato soup, which has potato chunks, it's different as far as how long will it take to go through and heat up the product. Those potato solids are going to take longer, and if there's something living in one of those potato solids, it may not heat up for a long enough period of time to kill it. Heat process of RTE. RTE is ready to eat. We've said this several times. Heat process of ready to eat meat patties. Oven temperature, time at that temperature, and patty thickness. The thicker the patty, the longer you've got to cook it. The greater the level of fat, the longer you've got to cook it. So, there's several things you've got to go through and look at there. Okay? Metal detection on a cereal line. Calibration of a metal detector. Sensitivity or capability. Acid addition to an acidified beverage. What's the pH of the finished product? How will that go through and affect it? And then what's the temperature? Will the temperature make a difference? If it makes a difference as far as temperature, then you've got to go through and have that, be a part there. Attachment 5. This is going to go through and walk us through our HACCP plan, and we can easily see here the main thing that's being added on this one: critical limits, monitoring procedure, person responsible. Just list out the facts here, and we're going to stop here. Okay, this will be picking up for the next one. Thank you.